Hi, it's Jan Beta and it's another Atari video. This time I'm going to try to repair an Atari 1050 disk drive. And the drive that I have currently set up here is a working drive that I got from Tim a while back. It's a bit noisy and it needs the belt replaced probably and some lubrication, but otherwise it works fine and we can boot up things like this DOS 2.5. I got another drive, this one, from Darren that looks in excellent condition, but it is apparently broken, so we're going to try to fix that. As a Commodore 64 native, so to say, I was a bit confused by the fact that these Atari 1050s have an auto boot feature actually. So the way that you boot stuff is by turning the drive on, putting the disk in, and then turning the Atari on or resetting it. And actually the disk is auto booted. There's also disks where you can load single files, but usually if you want to do something with your disk drive, you auto boot stuff. And there is a DOS disk in here, which we start DOS from, and it auto boots a few sectors, and then you can type in DOS and boot this menu, for example, or boot something else that you want to load. And this has a number of functions on it that you can use from this nice menu here. Whole different story on the Commodore 64 where you have to remember the syntax for some BASIC commands, which BASIC has DOS built in basically on the Commodore 64. And Atari auto boots the first sectors of a disk, and you can put like a menu on there, or you can have the full-fledged DOS on your DOS disk and use that for manipulating disks. Yeah, so this is the working disk drive. We are going to put that aside and use our non-working disk drive instead. I'm using my power supply that I built in the last video, so if you want to check out the build of this, watch the last video. So here's this particular Atari 1050. It looks in very nice condition, pretty clean, and not yellowed at all from the outside. It has 4 screws on this back part, and it has 2 screws on this front bezel part, the brown part that we have to remove in order to get to the inside, which is the first thing I want to do, because I don't want to hook up this drive without seeing what's going on in there. This has a whole power supply section in there that might be broken, so I want to look inside before I do anything with that. This should now come apart. So this is how these look from the inside. We have the drive mechanism on here, and we have the circuit board underneath. And we can lift this out. This is just sitting on here loosely and is press fit by the rest of the case to hold it in place. These connectors here are a bit weird because the center one, as you can see, is connected the other way round. These are actually, yeah, these are 1, 2, 3, 4, 5 connectors. Wow, okay. And obviously we want to be very careful removing these. Don't want to rip any of the cables out there. Probably going to use some pliers. Go. Oh, and I can, whoa, okay, I can see why this drive probably has problems powering on. This is completely loose. This capacitor here, which these are huge filter capacitors. The power supply provides AC to the drive, and that is rectified and filtered on board here. There's another connector underneath the mechanism, I think. Yep, that's on the front here. Okay, now we can separate the whole mechanical part. There's a metal can that's shielding the delicate electronics. I think there's a processor on here and things like that, and that's shielded from the mechanics, obviously, because those might interfere. If you have a motor running on top of a CPU, for example, it is going to produce quite a lot of electromagnetical disturbance. This is quite neat. There's a dual switch here, which you can use to set the drive to another drive ID, actually. And there's two. There's a white switch and a black switch. So you can set both of these to different positions to get another number. And you can see them through this hole in the case here and set them as well with some kind of pokey bit. Okay, this whole circuit board should just come out. It's just clipped in here with these little plastic clips, I think. Yep. Oh, okay, there we go. And of course you have to finagle the connectors here out of the holes in the plastic case. Okay, there we go. Let's see how bad our capacitor issue here really is. Yeah, these are completely cracked. That's not going to work very well. And there's I can see right away that this chip got replaced here. Oh, it's an amplifier chip, I think. LM3086. I am just going to fire up my soldering iron and resolder these joints there. So here's our joints, and I think you can see these here, that they are wiggling. If I wiggle from the other side, you can see the capacitor legs wiggling there. So first thing, I'm just going to put some new solder on there. And now it's no longer wiggling around. I'm also going to clean up the solder residue there that I didn't cause. It was somebody who worked on this previously. It doesn't look great, the soldering on that. Maybe I'm just going to resolder the whole thing as well. So it does look okay-ish, but there's clearly some of the traces have been scratched a bit, so maybe it's a good idea to check for continuity there. Probably going to resolder all of them at first and then check for continuity. Yeah, I just looked up our little chip here, the LM3086N, and that's a transistor array. So there's a number of transistors in this DIP package there, probably for amplifying the signals, I guess. Yeah, we are going to check the continuity from the pins there. And yeah, with these old circuit boards, you can mostly see where each trace is supposed to be going. And we're just going to follow that and measure from the pin to the pin it's supposed to go to with our continuity test. And yeah, that's going to be fun. Yep. This is not connected. This is supposed to be going here. This is supposed to be going here. This isn't connected. Oh, it's ground. Okay. This one's ground too. This one goes here. This one goes here. And somewhere underneath here. This one goes here. Okay. This one is probably ground. Yep. This one goes here. And this one supposedly goes here, and then underneath this can. So yeah, the connections are all there, even though it looks a bit shoddy, but that should be fine. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype circuit boards of all kinds. They offer premium quality PCBs for a very reasonable price, and they have very quick turnarounds and fast delivery. And they also offer excellent service. Check out the links in the video description. Back to the Atari disk drive. So I think I want to remove this can here next. And actually, it's not soldered on. There are just these tabs that we can twist. to remove this, I think. So yeah, this goes on. Yeah, so we should be able to see the chips now. Yippee! And they are all socketed, which is pretty nice actually. And we have these adjustable resistors here that we can use to adjust a couple of things, but they are all sealed in place with some silicone paint, I think. So we're not going to touch these for now. It's always a good idea if you have socketed chips to just push down on them gently to reseat them in their sockets just in case they got loose over the years. I think the main issue with this drive very likely was this capacitor not being soldered in correctly. We are going to check the power supply section. There are some rectifier diodes that I want to check, and there are 2 voltage regulators actually, one for 12 volts, I think this one, and one for 5 volts, I think this one. 7812 and 7805 voltage regulators, linear voltage regulators. And these big diodes here are the rectifier diodes. So we are going to check these. And we are probably going to end up replacing the voltage regulators altogether, because if this capacitor was loose for some time, maybe the voltages that these got were not very smooth, so they might get damaged in the process, although they are usually pretty sturdy. But first of all, let's check the diodes. So these diodes usually have a ring on them. That's the negative side, and the other side is the positive side. So we are going to put our multimeter in the diode test mode, which is this symbol, and then we are going to measure these diodes. Usually you can do this in circuit, and you should get a forward voltage, which in this case is 0.5 volts, which sounds reasonable. Yeah. Yeah, they all seem alright. There's some other diodes here that I also want to check quickly. If I can reach them. Yep, the diodes seem to be okay. That seems to be okay. So far, so good. Our power supply section is out of the worst. So we are going to check the linear regulators, I guess. Not sure if I want to replace them right away. Yeah, probably should. You usually don't have to do this, but as I said, I'm doing this because maybe they got damaged because of that capacitor being loose and making intermittent contact or something like that. I'm just going to play it safe here because these drives are rather valuable and are getting quite rare. I'm going to replace this 7805 with a 78S05 and the 7812 with a 78S12. These are rated for 2 amps. That's what the S means. I like these a bit better because they can draw more current and not burn. So let me just replace the voltage regulators and see. And I think after that we can try and test the board and test the voltages on the board. So that's our 7812 removed, and I'm going to clean up the old thermal paste there and add a new one. So this is our new 78S12. They have the exact same pinout. I'm adding some thermal paste there. So I want to screw this down before I solder it, so we don't rip out the pads there. And then we're going to do the same operation with the other voltage regulator, the 7805 on the other side. $78.05. Okay, so after checking the diodes, and I also checked the other solder joints that look rather good, and replacing the voltage regulators, I think I now want to power up this part of the drive. The drive mechanics we are going to look at in a second. I'm going to use my power supply that I made, and I'm going to hook up the drive. I put some contact cleaner into the power jack there, and we should be able to power this up without the rest of the drive connected, so we don't risk blowing that up. The voltage regulator is basically the 5-volt voltage regulator. The 7805 is responsible for powering all the logic and the ICs, and the 12 volts are mostly for the drive motors. And the power supply supplies 9 volts AC, which is rectified with the diodes and smoothed out with the capacitors on board here. So yeah, I think I want to power this up and check the voltages and see if we get our DC voltages at the voltage regulators. Okay, turning on our power supply. And we are also flicking on the switch here. Our drive LED is turning on, which is a good sign, obviously. And we should have ground on this heatsink here. And we should have our voltages on the rightmost pin. This is the 12 volts regulator. That's 12 volts. That's nice. And we should have 5 volts on our 5 volt regulator, which we do. This is very much spot on. Okay, we have our power supply fixed. Can't say if any of the chips works or if our drive is going to work. We are going to look at the mechanical part and check that. So here's our mechanical part of the drive. If you put a disk in, you can see that our read-write head is on this assembly here and slides on these rails. And the actual head, the magnetic part, is the thing on the bottom here. So the disks are actually read and written to from the backside, as usual in these 5¼ inch drives. Or if they are double-sided drives, there's 2 heads, one for the top part and one for the bottom part. We have our motor that spins the spindle, which is here. And we have our little stepper motor that positions the head. And yeah, in this case, there is no belt for the spindle. That is this part here. This is the motor, and we should have a belt going through here. So what we want to do is to add a new belt at first. We're not going to be able to really lubricate this because it's a closed system, but we are going to put a drop of oil on here so we don't get any squeaking noises from here, and also on here. I'm just using some silicone oil, I think, before we put the belt in. Just going to put a drop of oil on here and one on here, and yeah, going to take the excess away. We want to clean off the remains of the old belt that probably was in here with alcohol. I always want to clean this up nicely so the new belt is going to be able to grip. I heard some people use acetone for this, but usually, in my experience, you get away with just using some IPA, isopropanol, or isopropyl alcohol. In order to put a new belt in, you can get these belts from various sources. I'm not quite sure where this came from. Oh, Console 5 is one of the places you can order these belts. You want this belt works for several drives because they all used the same drive mechanism basically, and this is the 1050s are basically all the same as far as I know. These are pretty nice fabric reinforced belts. They have a fabric side which you want to use for the outer side, and a non-fabric side which you want to be using for the inside. That's the side that grips. Of course, you don't want any lubricant on your hands while you're doing this, because you don't want the belt to be slippery. I am going to slide this in here. I'm going to have to do this from the top side, I think. Yeah, that's going to be pretty difficult to do, but we're going to do it anyway. And you don't want to use magnetic tools close to the head, obviously. Yeah, so that should be in. I found the way to do it was to pull this through one of these openings here, and from the top side pull it over this cone-shaped spindle here, and then put it into the position that it needs to travel on. It actually supposedly sits on this flat part in the outer parameter, and then pull it over this motor pulley here. I now want to lubricate the rails that the head travels on with some silicone grease. You can use white lithium grease, which actually some people prefer. I'm not sure. I used silicone grease a number of times now. Multiple thousands, hundreds, probably hundreds of times on drives of all kinds, and it worked well. I am going to clean these rails with some IPA before I apply my grease. You want something that is not liquid, because it needs to stay on there. You want to clean off the old excess lubricant that's on there. So I'm using this stuff, which I've used many, many times, and you don't need much. Just a tiny little bit. And it's going to work itself in once the head moves a bit. And of course, we want to clean the head. So for cleaning the head, I'm using a Q-tip that I soak in isopropanol, and I'm putting it on here. There's a little felt pad on top there on this arm that pushes down the disc, and we want to clean that with the head. Actually, we don't want to bend this too much upwards, because there's a spring, it's spring loaded, and we are going to wear out the spring pretty easily if we move that too much. I am going to polish this a bit, and I'm using the other side to clean off the alcohol. There we go. Okay. We can actually lubricate the other moving parts a bit as well. Usually put some silicone on there as well. There are some places where this moves. And yeah, I'm just going to put some grease on these. So we have smooth operation. There's also this micro switch that I'm going to spray some contact cleaner into. That is for detecting whether we have the mechanism closed here. Just going to try and spray some in there and then work it a couple of times. But this drive is really clean, so I'm not too worried about the mechanical part of it actually. So I guess it's time to preliminarily put this back together. Okay, this should probably be a functioning drive now, I hope. And by the way, similar to the 1541 or the Commodore disk drives, there's two connectors, two SIO connectors on the back, and they're just connected in parallel, so you don't need to worry about which one you use for connecting these drives. Okay, fingers crossed. I'm just going to try to see if this works, I guess. Okay, turning this on. Turning this on. Doesn't even spin up. Okay, that's a bad sign. It does do something. It does want to do something. It's humming. Might have a broken motor in there. Back to the drawing board. Yeah, as I said, this does turn on the light, but it's not turning on the drive mechanism. So maybe we have a broken motor. Whoa, and this heatsink gets hot really quickly. That's not normal. That's not good. Okay, probably, maybe we have a shorted motor in there or something like that. Okay, so I disconnected this again, and let me show you this. I'm measuring the output of the 7812 against ground, and we have 0.5 amps against ground, so that's pretty much a short. The 12 volt rail is pretty much supplying the motors in the drive, so I am going to attempt to disconnect this stepper motor, no, this spindle motor here. I think that might be our issue here. Disconnecting the motor, and I'm going to try to power this on again. So I disconnected the motor connector here with the colored wires. So we should maybe not have a short on the 12 volt. Oh, it's still a short. Okay, so it's the other motor probably. It's the stepper. This should be the connector for the stepper motor. Let's see if we still have a short. We still have a short. Don't see a short here on the drive connector. No, that's okay actually. I did measure the voltages without the whole drive mechanic connected, so we have a short on our 7812. So I'm going to desolder that again, I guess, and see where we go from there. I was looking for a short and then I found a short. Okay, so that's not shorted. Let's see if we have a short on the circuit board. Yep, we have a short on the circuit board. Well, that's not good. Yeah, but at least it's not the motor. It might be one of those capacitors, I guess, or one of those diodes. So I have printed out the schematics for this drive, and actually from the field service manual that I'm going to link in the video description. And this is our 7812, and we have a short between the output and ground. So there's not much that can go wrong there. We basically have these capacitors. This is C68, C66, C65, C70. And obviously it could be that we have something going wrong here, but we basically checked the diodes, and that shouldn't be an issue. So I guess it might be one of these capacitors here that is just shorted. Our 7812 is not shorted in itself, but we have a short on the board with that removed. So there probably is a bad capacitor there. So I think what I want to do is to test these C70 and C65 at first, and then go on and check these. And yeah, check further down the line basically. The motors seem to be alright. I measured all the connections on the motors, and if a motor winding was shorted, which happens, actually we should have measured something there, and we shouldn't have a short on the board without the 7812, obviously. Yeah, basically this should be capacitive coupling, not a short. So probably one of those is short. Let's see. So here's our C70, C65, and yeah, that's the one the two capacitors I want to check first, I guess. Okay, I removed this from the equation by desoldering one leg. Let's see. We still have a short. Yep. Still have a short there. So maybe it's C65. The short obviously is on all the components in the way there, so difficult to tell which one is the culprit. Further investigation is needed. What on earth is shorting? Something in the path there. Okay, I think I found the issue here. It's actually really capacitors, but they're not on my schematic here. They are further down the line. Actually, we don't have a short anywhere now, and I desoldered C42, which is okay, but C43 is a dead short in both directions. So yeah, C43, which is a 47 microfarad capacitor, is actually the issue, I think. I'm going to replace all the electrolytic capacitors anyway, so yeah, I'm probably going to start with the smaller ones altogether and replace all of these. I think I have all the smaller values. The larger ones I am going to put in these for now. And yeah, then we are hopefully going to have a working drive electronic here. Yep, that's the one. C43. I think I want to replace all the small 47 microfarad ones there. Yeah, I also need to reconstruct the rest of the circuit. The components are desoldered, obviously. The other capacitors and things like that, so I'm just going to resolder those, I guess. Yeah, I'm going to replace all the small capacitors. They are all prone to failure. Fortunately, there are no capacitors, no electrolytic capacitors at least, under this shield, so we don't have to remove that again. Unless one of the chips is also broken, or more of the chips, you never know. So here's my little cap, and I got out the Atlas ESR meter. Let's see what it says. Probably it's not. Oh, it's displaying an ESR, but it displays in circuit or leaky. That means the cap is just shorted. It's clearly not in circuit anymore. Yeah, that's a broken cap for you. So I'm now just going to replace all the capacitors, and actually I bought some of these Nichicon capacitors on eBay. These are 6,800 microfarad and 35 volts, just like the ones that were in here. I'm just going to use these. I measured them on the ESR meter, and they are probably not Nichicon, but it's really difficult to get quickly get brand caps from reliable sources, so I went to eBay, and these were the quickest ones I could find. They are fine regarding their capacitance and their ESR. They are probably not real Nichicons, but yeah, they are, at least they are modern caps, and we are going to replace these big ones. And for the small ones, I think I still have them in my parts bin. So recapping the whole board, replacing all the electrolytic capacitors on here. Let's go! The new capacitors for these big ones are a much smaller footprint, as I've shown you. And actually on the board there are holes for smaller footprint capacitors as well. So that's pretty neat. Okay, I think that should be all the electrolytic capacitors replaced with fresh ones. Oh, and I think I want to resolder some of those, the connectors, because those tend to develop cracks of all kinds that are very painful to troubleshoot. So I'm just going to put some new solder on there. And obviously we need to replace that voltage regulator again. I'm just using a new one just to be safe. The old one is probably fine, but I have a couple of those in stock, so just going to put this one in, which is a completely new one. And I also checked for shorts again. There's no short anymore on the 12-volt rail. So hopefully, not quite sure why that capacitor was faulty, because I measured this without the motor assembly connected there, and it provided 12 volts. Usually, if you short out a rail to ground, it doesn't provide the voltage it's supposed to provide. So maybe something still is rotten with the motor assembly. But at least we don't have a broken cap on there. Maybe, I think, maybe what happened was that the motor was stuck a bit because it didn't move in a long time, probably some decades. And yeah, the whole power supply section drew too much current. So it might be that that caused a capacitor that was on the edge of failing and shorting out to fail completely in the end. So that might be what happened. That would be an explanation why we got proper 12 volts before and didn't get 12 volts after. Okay, let's try this. Pouring this thing on, pouring this thing on. Hopefully nothing explodes on my face. Doesn't seem to explode in my face. That's good. Okay, measuring the voltages. So this should be 12 volts now. Which it is. It's super stable. Okay. This should be 5 volts, which it is. It's also super stable. Okay. There are some test points. This should be our 12 volts test point. I'm not quite sure where. So TP14 is our 12 volts test point. I'm not quite sure where the other one is. The 5 volts test point, but we tested on it should be 5 volts probably. Yeah. This is on a chip on an IC here on our amplifier transistor array. So we have 5 volts going through the board and we have 12 volts going through the board. And we don't have a hilariously hot heatsink here. So yeah, probably we don't have anything wrong with this board at this point, hopefully, at least power rail wise. So let's hook up the drive mechanics and see if we get somewhere, anywhere. Okay, time to hook it up to our power supply here and cross your fingers, powering this on and see if we get a spin. Yup! Yes! Okay. That might just have fixed it. We got a spin and our stepper motor moved the head to the track 0 position. That's pretty nice. Very promising. Let's hook up the Atari. Okay, I have everything connected up. Let's turn on the drive. It's doing its thing. Turn on the Atari. We get a boot error, but that's to be expected because we didn't have a disk in there. So we can put a disk in there. Should be able to put a DOS disk in there and it should boot off the DOS disk. Which I think it does. Okay. Should be able to enter DOS now. And it's doing its thing. Let's see if we are able to boot up DOS. Yep! Nice! It seems to work. So, yeah, let's have a directory. And it works. It seems to be pretty well aligned as well, which is fortunate. So it reads disks and we can boot stuff. Yeah, this seems to work fine. Let's try some stuff. I have some disks thanks to Tim, who donated the other drive. And yeah, we should be able to boot some stuff. And I now booted Pitfall, which is pretty nice. Okay. It worked with the option key pushed down. I don't know if that usually prevents the Atari from loading BASIC into memory. So for some games, that's needed, actually. So the drive itself seems to work fine, actually. So that's good. Wow. I suck at Pitfall. Oops. Yeah, as you can see. But that's just to prove the point that this drive is working. So let's try some other stuff. It does work fine. Oops. Okay, it's crashing. Might still have some issues here. Yeah, unfortunately the fuse in my power supply blew, which is fortunate in the end because clearly there's something wrong with the drive still. The power supply actually opened it up and checked it, and it all seems all right. I put a new fuse in and that blew again after turning on the drive. So I think we still have a problem here. And I also noticed that the heatsink got too hot in the drive. So maybe we have another problem here that I don't know quite what it is. Maybe one of the diodes blew. I'm not sure. As I said, there might be a huge current draw if one of the motors is stuck. So yeah, maybe that's the case here. I am going to disconnect the mechanics again, I think, and try to power this on again. Maybe that's the correct way to do it. Clearly something is still wrong there. That's super unfortunate. I was so happy that I got this working. But yeah, it does react as it should react, I think. Nope. Completely off again. So there's something wrong with the board, I suppose, still. Something's shorting out on our board there. I'm just going to remove the whole mechanical part again, I think. And double check things. Okay, it doesn't even power up now at all. That's no good. So we probably have a dead short somewhere. Wow, that is unfortunate. So it does power on now. Let's quickly check our voltages, I guess. That should be 12 volts, yes. That should be 5 volts. That's 5 volts. Okay, that's super strange. Something's shorting out there. Intermittently, probably. I'm not sure what. So now it actually seems hunky-dory again. I'm not sure what's happening. So our 5 volts should be here, which they are, and our 12 volts should be here, which they also are. And our LED is lighting up, and the fuse is not blowing in the power supply. I'm not sure what's happening. Maybe we got a problem with our power input socket there. I'm not sure. Intermittent faults. You gotta love them. It's actually, yeah, I guess there's a spark there. Yeah, I guess we need to replace that. So I'm just double checking this with my known working drive, and the connector feels a lot different. And also, it doesn't short out anything, even if I wiggle on it. So yeah, it's definitely the socket on the drive that we are repairing, or that I am repairing at this point, that's broken. So we need another one, a better one, a suitable one. So long story short, I am just going to open up another 1050 drive. This one has a mechanic that's a bit stuck, but the power connector seems to work fine. So we are going to salvage the power connector for now, for this repair, until I source a proper one, because I want to get this repair out of the way, basically. That's not the best way to do it, obviously, but at least it's going to allow me to continue troubleshooting. Yeah, this is more like I would expect one of these drives to look. It's really crusty. And there's broken off plastic parts as well. So yeah, this one is going to be another repair. Just need your power socket. There we go. Desoldering the broken one. Okay, nice. So let's see if we can fit the new one in here. That looks good. Okay. Yes. That should be pretty much it, I guess. Okay, let's try that again, shall we? Yeah, it already feels better, actually. So, turning this on, turning this on. Okay, now it seems to work. And I can actually wiggle this. Yeah, we definitely had an intermittent short in this bugger here. Okay, so that fixes that issue. Should we maybe try to make this a working disk drive again? Yay, maybe. Got the drive mechanism hooked back up. Let's try that again, shall we? Turning on the power supply, turning on the disk drive, which turns on nicely and hopefully stays on. Okay, we got DOS. At least we got DOS. Directory. Got a directory. Yeah, and the heatsink doesn't get as hot. That's good. Maybe this works. Let's try to boot another disk. Yeah, it does seem to work now. And we don't get to temperatures that are as hilariously hot as before. So I have high hopes that that actually was the last fault. Yeah, I guess that looks a whole lot better. Option 1 player, 2 players, start to begin game. Okay. Player 1. Yep. And it does work indeed. This is proof that this drive now works. Yay! I fixed it! Okay, I'm going to do some very scientific long-term testing now, but I think that's it for this repair. Pretty stubborn drive. Thanks for joining me on this little adventure. My foray into Atari 1050 disk drive repair land. This was all new to me. I've never worked on one of these before, so I hope you found this somewhat enjoyable. And I hope to see you again on this channel sometime. Thank you for your support on Patreon and on the channel memberships page. Thanks for your comments, your likes, your subscriptions. Yeah, I'm Jan Beta. Thanks for watching. See you next time. Bye.